Bismillahirrahmanirrahim. Welcome to lecture number 13 for the course CS 325 Data Science. We will continue our discussion on plotting in Python. This is the discussion agenda. So today we will talk about two assignments. So this is assignment number 4 is basically looking to the graph and try to understand some misleading information. Then we continue our discussion on matplotlib and discuss bar chart. Then we understand dejunkifying the plot, and then there will be assignment number 4, and we will talk about subplots and histograms. So let's go first to assignment number 4. So the title is Graphics Lies and Misleading Visuals. So a figure is given and it belongs to an American news and opinion website. Article title: Vegetarian India a Myth. Surveys shows over 70% Indians eat non-veg. Telangana tops list. This article argues that over 7% of the Indians are non-vegetarian, against common belief that India is a vegetarian country. The image is also strengthened by Honorable Indian Prime Minister, who is also a vegetarian. So this visualization is taken from this source, and what you have to do, your assignment is to locate and identify a visual that displays misleading information. There is some misleading information and you have to identify that. Then you have to identify mechanism for misleading, that is hiding relevant data or displaying too much data and obscuring reality and distorting data through graphic form, and explain how it is used to mislead. So go through the figure, try to understand the data, go through this website and try to understand the assignment, and then the solution is given at the end. But I suggest you first you go through the assignment, solve the assignment. Once you solve the assignment, then compare your solution with the solution that is given at the end of this assignment. Okay, so now let's continue with the bar chart. So this is bar chart. I think we can clean it. So maybe it doesn't work. So what I can do, import mat import matplotlib.pyplot as plot and plot.figure, and x values is equal to range, length, linear data, and plot.bar x value, linear data, and width is this. The linear data is taken from the above. So since we are not executing all the code, so I will just copy the linear data and the exponential data to make sure that our code executes. So maybe we can do like this. We copy this data. Okay, so this is our linear data and exponential data, and we try to create the bar chart for this linear data. Let's hope this code executes. Okay, something is wrong. Maybe we have not imported this one, so this needs to be executed. This is important, and we need to import pyplot. I think I have added correctly. I think there is nothing wrong in this step, so let's do this. Okay, so the problem was the inline. We have not enabled inline display. So you see how the bar chart is created to display linear data. Now we can have a new x value, and we plot another set of bars, adjusting the new x value to make up for the first set of bars plotted. So for item in x values, new x values dot append item plus 0.3 and plot dot bar new x values exponential data. Exponential data is coming from here, exponential data, and width is 0.3 and color is red. And let's see, we execute it and what happens. Okay, I just made a little not a mistake, but I closed the bar so I can reopen it. So let's open it. I just want to display the two figures comparable to each other. So you see the original figure is updated, and we have the linear data and the exponential data. So the plot looks okay, but not great. All of the x labels are to the far left of the items being described and not centered. We can center them with a given bar using the align parameter, but it's a bit frustrating when you have to make multiple bars and you have to calculate it yourself, and it's a pain to go through and add new data series manually. And this gets worse, we actually have to manually iterate through and add in dares if we want them, because otherwise we couldn't set the bar left location appropriately. There are some other nice features of bar charts though. For instance, you can add error bars to each bar as well using the y_error parameter. So to display error bar, we have from random import rand integer, the rand integer 0 to 15 for x in range, length of linear data, and this line will plot a new set of df bars with error bars using the list of random error values. So plot.bar x values linear data with y_error linear error, and I think something is displayed here. So this is the error between the two components. There is another type, the stack bar. So we can stack bar charts by using this code plot.figure X values is equal to range, length of linear data, plot.bar X values, linear data, width is equal to 0.3, color is blue, and we have plot.bar X value, exponential data, width is 0.3, bottom is linear data, and color is red. So let's try to execute this code. So you see it's a stack bar. The bottom blue color shows the linear data and the red color shows the exponential data. Horizontal bar charts. We can use bar H for horizontal bar charts. So let's create a new figure, plot.figure, with the X value, range, length of linear data. We plot bar H, X values, linear data, height is 0.3, color is B, and plot.bar H, X values, exponential data, height is 0.3, left linear data, color is red. So this is how the figure is shown horizontally. Now there is a topic that is called dejunkifying the plot, and in this code we will give you two solutions. One is this solution and one is what you can think about yourself. So these two solutions are given. So let's see. So we import matplotlib.plot and numpy and create a new figure, and we have languages Python, SQL, Java, C++, JavaScript, and we have let's say position is np.arrange, length languages, and popularity, so 56, 39, 34, 34, 29, and bars is equal to plot.bar with the position, I mean these languages, popularity, and align center, and color is light gray. We set bar 0.setColor, this is a code, and plot.xtics, pose and languages, y label, percentage popularity, and a title is given. Now we can remove text by setting the length to 0. So plot.tick parameters, x is both, which is both, and length is 0. And removing y-axis label, you can remove by plot.gca.axis.y-axis.set tick labels. Removing the frame, so for spine in plot.gca.spines.values, spine.setVisible false. We can have direct labeling, so for bar in bars, h is bar.getHeight, and plot.gca.text, x is bar.getX plus bar.getWidth divided by 2, y is h minus 4, and s, and there is another HA center and VA center, and we can have plot.show. So this is how you can create a good looking bar. We have removed the lines for the x-axis and the y-axis, and we have placed the label on this side, and we have placed the popularity on the top of the bar, and we have enabled only the highest one because this one is sorted. So it's actually a good looking graph. This is another way that you can clean the graph. You can dejunkify it. So think about yourself if you can make it more clean, more readable. So that's for your own benefit, that you can create better presentable graph. So let's go to assignment number 5. So this is assignment number 5. Actually, some code is given, some description is given. So this data is provided, and for this assignment, so you have to read this documentation, and then you have to display the graph, and this graph is displayed here. Well, this figure is not, because I may not have installed MPL leaflet, but try to install it and see the data for yourself. So this is all the code is given, and you can go through the assignment and try to understand for yourself how this assignment can be completed. Remember, first try to solve the assignment yourself, and then compare your solution with the solution that is provided. Now let's go to the new topic. And that's about subplots. So we have been using a single axis object to plot a single graph or figure. Sometimes it is used to show two complex plots side by side for the viewer to compare, and Matplotlib handle this with a single figure. So we do Matplotlib notebook, matplotlib.pyplot as plot, numpy as np, and this is just a description of the subplot. You can go through this description, the signature is given, and all this information is given, so just go through it and try to understand for yourself. This is the signature to call subplot. We provide number of rows, number of columns, and plot number. So this sets number of rows by number of column grade, and set the plot number as the current axis. So we create a new figure, plot dot figure, and subplot with 1 row, 2 columns, and current axis is first subplot axis. We have plot dot subplot 1 by 2 and 1. Linear data is this one, and we plot linear data. Before I execute it, let me clear the previously executed code so you can better understand for yourself. So you see, this is linear data. We have created a subplot, and only the first subplot is visible here. Now we have exponential data, so linear data to the power 2, and subplot with 1 row, 2 columns, and current axis in second subplot axis. So plot dot subplot 1, 2, and 2, and plot dot plot exponential data with the O. And something has changed. So this is exponential data, and this is linear data. Now the norm with Matplotlib is that you store the axis object that you get back from the subplot, but you can call subplot again at any time with the parameters that interest you in order to get back a given axis. So we can plot exponential data in first subplot axis, plot dot subplot 1 to 1, and plot dot plot exponential data with x. Let's see. So you see, we can plot same data. This is the linear data and this is the exponential data. So we have another problem that's called locking y-axis, and this demonstrates a common problem. It looked like linear had roughly the same area under the line on the chart until we asked Matplotlib to put them into one graph. Then the y-axis was refreshed. There would be a big problem when misleading the reader if we didn't find a way to log axis between two plots. When you create a new subplot, you are able to share x, y or both axes using the share x and share y parameters. So plot.figure creates subplot on LHS and store in x1. So x1 dot plot.subplot 1 to 1 and plot.plot linear data with the O, and we can pass share y x1 to ensure the two subplots share the same y-axis. So x2 is equal to plot.subplot 1, 2 and 2 and share y the same as x1, and we have plot.plot exponential data and like this, and it looks much better. This is now the y-axis are shared for both the graphs. There is a shorthand notation, so we create a new figure, and plot.subplot 1 to 1 is the same as plot.subplot 1 to 1. It's just the same. We create a 3 by 3 grid of subplot. So figure AX1, AX2, AX3 and 4, 5, 6 and 7, 8, 9, and plot.subplot 3 by 3, share x is true, share y is true, and linear data only on the AX file. So this is a 3 by 3 grid, and only the fifth grid shows the linear data. The y-axis is shared with the all graphs, and also the x-axis is shared. The results look very nice, but note that this method turns off the y-axis and the x labels except for those plots which are on the left hand side at the bottom of the figure. If you want to turn the labels back on, you need to iterate through the axis objects and do it yourself. You could do this directly through the axis objects you have, or iterate through all the axis objects in the figure and change the x and y text labels to be visible. So we can set inside tick labels to visible. For x in plot.gcf.getAxis, for labels in ax.getXTix labels plus x.getYTix labels and label.setVisible true. And we can go back, and this is something is changed. Well, this is in some system which is necessary, but not in our case. Now the last topic is histograms. So histogram is a bar chart that gives a frequency of a given phenomenon. Probability function can be visualized as a curve where the y-axis holds the probability of a given value that would occur, and the x-axis is the value itself. This is called probability density function. The y-axis values are limited to between 0 and 1, where 0 means there is no chance of a given value occurring, and 1 means that the value will always occur. The x-axis values are labeled in terms of the distribution function. In the case of the normal distribution, this is usually in terms of standard deviation. So a histogram is just a bar chart where the x-axis is a given observation and the y-axis is the frequency with which that observation occurs. So we should be able to plot a given probability distribution by sampling from it. Recall that sampling means that we just pick a number out of the distribution, like rolling a die or pulling a single card out of a deck. As we do this over and over again, we get a more accurate description of the distribution. So we create a 2 by 2 grid of axis subplot. So x1, x2, x3, x4, and plot.subplot 2 by 2, share x is equal to true, and axis is x1, 2, 3, 4. Now we can draw n for 10, 100, 1000, and 10,000 sample from the normal distribution and plot corresponding histograms. So for n in range, sample size is this. Sample is np.random normal distribution with a scale 1 and sample size, and axis.histogram sample, and we can have a set title. So this is how the histogram for different values of n is displayed. Now these bins are not something that is very smooth, so we can increase these number of bins. For example, here by default the number of bins is 10. So here we have number of bins equal to 10, but we can increase to 100. And this looks much smoother. So let's say we have a diagram like this. It's a scatter plot. And how we create it? We create a figure. We create a random normal distribution with a size 1000 and x is normal distribution with the same scale as the y-axis, and we plot dot scatter x y. Now we can use grid spec to partition the figure into subplots. So we import matplotlib.grid spec as grid spec and create a new figure, plot.figure, create a 3 by 3 grid, grid spec.grid spec 3 by 3, and top histogram plot.subplot gspec 0 1 colon, side histogram plot.subplot gspec 1 colon 0, and lower right plot.subplot gspec 1 colon 1 column. So here we will show our scatter plot, and here we will show one histogram, and here we will fill on another histogram. So let's set on the values for the x-axis and the y-axis, and the lower right scatter xy, and top histogram is this one with the bins 100, and the side histogram is this one. So let's do this. So this is histogram on the x-axis and this is histogram on the y-axis. So we can clear the histograms and plot normal histograms. So top histogram dot clear, top histogram dot hist with the bins 100 and normal distribution is true. Side histogram clear with and side histogram with the orientation horizontal and normal distribution is true. So this is how it looks like. We can do this one by changing the x limits. And if you remember, we have seen this figure at the beginning of this course, so you can go through that image and see for yourself how that image can be created by using this code. I think we should stop it here. Thank you very much.